This is your Prabhakar and welcome to our channel Dawn of Chemistry. We have been discussing about the thermochemistry. In the thermochemistry, today we are going to discuss about the enthalpy of neutralization. Enthalpy of neutralization. Very important concept. So what is this enthalpy of neutralization? And definitely you can expect a question touching on this enthalpy of neutralization. This is having a great significance during the calculation of the acids and base reactions. So to study acid and base reactions, this is very important thing. So let us see what is this enthalpy of neutralization. You know very well, neutralization means H plus and OH minus react to form water. So during this time, some heat will be liberated. That is nothing but the enthalpy of neutralization. So amount of heat liberated when one equivalent of H plus ions react with one equivalent of OH minus ions, or 1 mole of H plus ions react with 1 mole of OH minus ion. So always remember, this is always exothermic in nature. So amount of heat liberated when one equivalent of H plus ion react with one equivalent of OH minus ions, or 1 mole of H plus ions react with 1 mole of OH minus ions is called as enthalpy of neutralization. This is very important. Why I am stressing is, see, H plus and OH minus ions, you know, equivalence is equals to n factor into moles. For them, n factor equals to 1. If you define the definition in terms of moles or equivalents, it will be same. But when it comes to the polybasic acids and polyacidic bases, the definition has to change. That is, the amount of heat liberated when one equivalent of acid reacts with one equivalent of base is called enthalpy of neutralization. So the amount of heat liberated when one equivalent of acid reacts with one equivalent of base is called as the enthalpy of neutralization. We should not mention this in terms of 1 mole of acid or 1 mole of base, because if it is monobasic acid and monoacidic base, like HCl plus NaOH gives NaCl plus H2O. Here 1 moles of H plus ions and 1 mole of OH minus ions is there. You can expect some amount of heat, but you take 1 mole of H2SO4 and 1 mole of CaOH twice. Here it gives 2 moles of H plus ions, it gives 2 moles of OH minus ions. So that's why the heat liberated will be double. So that's why mentioning this thing in terms of moles is not proper. You have to mention in terms of equivalents only. So it will be producing CaSO4 plus 2H2O. So amount of heat liberated when one equivalent of acid reacts with one equivalent of base is called enthalpy of neutralization. What is the value of this? Means delta H neutralization is minus 13.7 kilocalories per mole, or minus 13.7 kilocalories per equivalent. This is mole we are telling in terms of H plus and OH minus ions only. So be careful with this thing. Or if you want to say in joules, means minus 13.7 into 4.8 you do means minus 57.3 kilojoules per equivalent will be coming. That is the introduction to the enthalpy of neutralization. This is a very important thing. One small application is there for this. I will explain that after doing some problems. Let us say 1 molar HCl of V1 ml reacts with 1 molar NaOH of V2 ml. Just go with 100 ml is reacting with 200 ml. Delta H neutralization is how much? See here. 1 molar HCl of 100 ml, 1 molar NaOH of 200 ml. When they are reacting like that, all acid and all base does not react. So which is the limiting reagent for HCl? Number of equivalents is equals to N1V1. So that's why 100 milli equivalents. Number of NaOH, number of equivalents is equals to N2V2, or you can simply take NaVa. This will be NbVb. This will be 200 milli equivalents. Which is less means this is less. So that's why heat liberated is equals to number of equivalents reacted into 13.7. The whole value will be minus. So how much is reacted means whatever is the lower quantity that will be reacting. So that's why 0.1 into 13.7. So minus 1.37 kilocalories heat will be liberated. This is a very important model. Whenever certain quantity of acid and whenever certain quantity of base reacted with one another, whatever is in the lower value, that only we have to take. So number of equivalents is NaVa, NbVb, and finally heat liberated is number of equivalents reacted into 13.7. This is one kind of model asking the question. They will give you acid and base in different volumes and you have to identify. First you have to find equivalents for both of them and then equivalents into 13.7. If they ask in joules means you can, no problem. By multiplying with 4.18 joules you can get the answer. The second model is, this is very important model, listen carefully. 1 molar HCl of V1 volume, 1 molar NaOH of V2 volume, one molar HCl of V volume and 1 molar NaOH of V volume combined with one another. The temperature was T1. 1 molar HCl of V liter, 1 molar NaOH of V liter mixed with one another. The solution temperature was T1. This is in part A. In part B, 1 molar HCl of 2V liters, 1 molar NaOH of 2V liters mixed with one another. The temperature of solution was T2. What is the relation between T1 and T2? See, 1 molar HCl of V liters, 1 molar NaOH of V liters mixed with one another. The temperature was T1. And 1 molar HCl of 2V liters, 1 molar NaOH of 2V liters mixed with one another and the temperature was T2. What is the relation between T1 and T2? Here 1V equivalent reacts with 1V equivalent. So the temperature was T1. Here how many equivalents are reacting? 2V equivalents is reacting with 2V equivalent. So the heat liberated is double automatically. Here 1V equivalent and 1V equivalent T1 is there. 2V equivalent means automatically temperature is doubled. So T2 also should be double than T1. But originally here T1 is equals to T2. Sir, why? The volume, you see, initial case volume was 2V after mixing them, so the heat liberated is absorbed by 2V. But in the second case, the heat liberated was absorbed by 4V. Of course, the heat is doubled. At the same time, volume also doubled. So that's why the water existing will absorb the heat in the same manner. That's why T1 is equals to T2. This is a very, very important question. In another case, 1 molar HCl of 1 liter, 1 molar NaOH of 1 liter reacted. The temperature was T1. 2 molar HCl of 1 liter, 2 molar NaOH of 1 liter mixed with one another. The temperature was T2. What is the relation between T1 and T2? See, initial case, one equivalent is reacting with one equivalent. The temperature was T1. In the bottom case, two equivalents is reacting with two equivalents. So the heat liberated is double, right? In the first case, one equivalent means minus 13.7 kilocalories is liberated. In the second case, 13.7 into 2 kilocalories is liberated. So the heat liberated is double. Since heat liberated is double, temperature should be double. So that's why T2 is equals to 2T1. So in the first case it is not same, by second case it is double, means see the volume to absorb is here 2 liters of water, here also 2 liters of water is absorbing. The water absorbing is the same, but heat liberated is double. So that's why temperature will be double, will be coming. This is a very, very important thing you have to understand. Be careful with this thing. And next you see, sir, if it is strong acid and strong base means there is no problem, they will release the heat accordingly. But if I take weak acid or weak base, what will be happening means, this is what you should be very careful about. Listen this carefully. This is a very important thing in case of the weak acids for mains level. Whenever you take any weak acid like CH3COOH plus NaOH, gives CH3COO Na plus H2O, weak acid, strong acid. The problem with the weak acids is they don't undergo complete dissociation, but once you raise the temperature means they undergo dissociation. So that's why whenever the acid and base are reacting, they form salt and water. That time they will give some amount of heat. They give some amount of heat. Let us take one equivalent of acid is reacting with one equivalent of base, means it will give minus 13.7 kilocalories, but the weak acid will not undergo complete dissociation. So to dissociate, it will absorb the heat from the solution. So the solution is formed by the reaction between them. So the heat liberated is absorbed by this acetic acid to undergo decomposition. So CH3COOH will dissociate as CH3CO minus and H plus. This is known as enthalpy of dissociation. This is always endothermic. So originally 13.7 should come. Since you are using weak acid, in place of this you can use weak base also. Same theory is applied for both of them. So whenever you take weak acid, it needs some amount of heat for dissociation. That's why it will absorb the heat from here. That's why enthalpy of neutralization is less than 13.7. This is a very, very important bit. For weak acids and weak bases, the enthalpy of neutralization will be less than minus 13.7 value. Why it is coming? Magnitude is less than 13.7. Why it is less than 13.7 is because some amount of heat will be utilized for the dissociation. So that's why the enthalpy of neutralization will be lower. So when you react one equivalent of acetic acid with one equivalent of NaOH means the heat liberated will be less than 13.7. So here you can take enthalpy of dissociation is equals to enthalpy of dissociation is equals to the enthalpy of experimental minus enthalpy theoretical. That means enthalpy experimental minus of minus 13.7. So enthalpy of experimental plus 13.7 will come like this. We can identify enthalpy of dissociation. This is a very important thing. So underline this very carefully. For weak acids and weak bases, we can easily identify enthalpy of dissociation by using this formula. How much should come originally means 13.7 should come. How much is coming exactly? We will identify. For identifying this thing, water calorimeter concept is there. No, bomb calorimeter and water calorimeter. I made a separate video. From them you can understand. So 13.7 plus enthalpy experimental will give you this thing. From this enthalpy of experimental thing, we can have another application. What is that another application? This is a very important application. So see, I was always mentioning from starting onwards very important, because the significance of this topic is that much. So that's why I am mentioning this. Degree of dissociation, that is alpha. Degree of dissociation can be calculated by using this enthalpy of neutralization values. Alpha is equals to enthalpy experimental by enthalpy theoretical will come. So from this thing we can identify the alpha value. You know very well where we can apply these alpha values. Let us say 2 molar acetic acid when mixed with 2 molar acetic acid of 1 liter when mixed with 2 molar NaOH of 1 liter, the heat liberated was minus -20 kilocalories. When 2 molar acetic acid of 1 liter reacted with 2 molar NaOH of 1 liter, the heat liberated was -20. What is the alpha value for acetic acid? What is the alpha value for acetic acid? You know very well, alpha equals to delta H neutralization experimental divided by delta H neutralization theoretical will come. So delta H neutralization experimental is -20 divided by, originally how much should come? 1 equivalent will liberate minus 13.7, 2 equivalents will liberate minus 13.7 into 2. 2 sevens are 14, 2 threes are 6 plus 1 7, 27.4 will come. From this thing we can identify the alpha value. So like this we can do problems based on this enthalpy of neutralization. So be careful with this thing. So what is enthalpy of neutralization? What is the definition for that thing? How to understand enthalpy of neutralization, and the values minus 13.7 and minus 57.3 kilojoules you have to by heart. These are very important values. And after that thing, when an acid and base mixed with one another, how much heat will be liberated, and how to identify enthalpy of dissociation for the weak acids. Always remember, enthalpy of dissociation will be endothermic. So you can find the difference between them and simply put the positive sign for that, simple. And you can identify the alpha value also by using this enthalpy of neutralization. That is for this video. Don't forget to like this video. Any doubts you have means you can put in the comment section, and subscribe to my channel for more updates. Thank you.